Problem number one, we have a system of forces. There are three forces, F1, F2, and F3, and they're given in terms of I, J, and K components. We'd like to find a resultant. Well, the resultant would be acting through the same point that the originals are on, and so as we look for the solution, it's easy to spot the fact that the coordinate 364 is where the answer would lie. But we can also go ahead and add these up, and we find that under the I we have these three components, which would give us a net of 25. This one would give us a net of 60. This one would give us a net of 55. So the answer would be that the resultant force is equal to 25I plus 60J plus 55K acting through the point 3, 6, and 4. Okay, in this next problem, we would like to resolve the 300 Newton force into two components, one along line P and the other along line Q. What we're looking for is F sub P and F sub Q. It's the two components. Well, if we were to define an XY system, which we're very comfortable and which we work with all the time, call this the y-axis and this the x-axis, we can take this force and we can resolve it into an F sub y component, which is equal to 300 newtons times the sine of this angle in here, because this is the way we've been doing it back in the review session, sine of 25 degrees. We can also find an x component. The x component would be 300 newtons times the cosine of 25 degrees. But also at the same time, in terms of Q, there's a component along here on the Q axis, and that component, if we were to try to relate that component to the Y component, we would come to the conclusion that the Y component is the same as taking the Q component times the sine of 70 degrees. Because the Q component makes a 70-degree angle with respect to our reference. So these two things must be equal. Similarly, down here, we can write this as being equal to F sub, along this line, we have an F sub P component, and we also have F sub Q cosine of 70 degrees. From this equation, I can solve for F sub Q, and once I have that value, I go to this second equation, and I can solve for F sub P. So basically it becomes two equations with two unknowns. Let's just put some numbers in here very quickly. We have that if we took the value of F sub Q out of this, F sub Q is equal to 300 newtons times the sine of 25 degrees divided by the sine of 70 degrees. And that's about 135 newtons, so let's put the answer in here, 135 newtons. And now once we have that, we go down here, put 135 in here, and we solve for F sub P. F sub P is 225.8. The details are fairly easy to calculate. The next question asks, which type of load is not resisted by a pinned joint? Well, with a pinned joint, forces are supported. Forces are transmitted, but not moments. Moments are not transmitted. Moments are not supported by a pinned joint. In this problem, we have three forces acting on a hook. We'd like to determine the magnitude of resultant of the forces and assume the hook will not bend. There are three forces, F1, F2, and F3. The magnitudes and angles are shown. We'd like to find the resultant of these three forces. Well, the straightforward way to do this problem is to resolve all three forces into their x and y components.